Welcome. In this lesson, we are going to review the building block of an image, which is the pixel. We will discuss exactly what is pixel and how pixel is used to form an image. And then we will see how to access and manipulate pixels using OpenCV Python. So, what is exactly pixel? Every image consists of a set of pixels. Pixels are the raw building block of an image. Normally, we think a pixel as a color or intensity of the light that appears in a given place in our image. If you think image as a grid, each square box in a grid is consist of a single pixel. For example, let us pretend we have an image with a resolution of 500 by 300. Which means that our image represents the grid of pixels with 500 rows and 300 columns. Overall, there are 500 into 3, that is 1,50,000 pixels in our image. Generally, the range of pixels can be defined by the bit of an image. For an n-bit image, the range of pixels is between 0 to 2 to the power of n minus 1. So, for an 8-bit image, the range of pixels is between 0 to 2 to the power of 8, which is 256 minus 1 is 255. Now let us try to understand the difference between color image and grayscale image. Most of the pixels are represented in two ways, grayscale and color. In grayscale image, each pixel has a value between 0 to 255, where 0 corresponds to black and 255 corresponds to white color. The values between 0 to 255 are varying the shades of gray, where the value closest to 0 are darker and the value closest to 255 are lighter in color. Whereas color pixels are normally represented in RGB color space, one value for red component, one for green and one for blue. Each of the three colors is represented by the integer and the range between 0 to 255, which indicates how much the color is there. Given that pixel values only needs to be in the range of 0 to 255, we normally use 8-bit unsigned integer to represent each color intensity. We then combine all the values into RGB tuple in the form of red, green and blue. This tuple represents our color. To construct a white color, we fill up each of red, green and blue buckets completely like this. Something like 255, 255 and 255. To create the black color, we would empty all the buckets of red, green and blue colors, which is filling up the values with 0. For your reference, here are the common colors represented in the RGB tuples. Black is 0, 0, 0, white is 255, 255, 255 and for red 255, 0, 0 and so on. Now we have a good understanding of the pixel. Let us have a quick review of the coordinate system of the image. As I mentioned above, the image is a representation of the grid of pixels. Imagine our grid as a piece of a graph paper. Using this graph paper, the point 0, 0 corresponds to upper left corner of the image. As we move down and to the right, both the x and y values increases. Let us look into the image as shown here to make the point more clear. Here we have a letter I. On the piece of graph paper, we see that we have 8 by 8 grid with a total of 64 pixels. The point 0, 0 correspond to the top left pixel on your image, whereas point 7, 7 correspond to the bottom right corner. Finally, the point 3, 4 is a pixel, 3 columns to the right and 4 columns to the down. So this is what the pixel and coordinate system of an image. In the next lecture, we will see how to access pixels and convert the color in OpenCV. Until then, happy learning. Hey guys, welcome back again. Now let us see how to display the image. As we can see that in the previous lecture, we have load an image, then we save in variable img. Now what we will do is that let us display this image. In order to display the image, I will show you the different ways of displaying the image. The one thing that is there in the OpenCV, which is cv2.mshow, and if you look into the docstring of this, it is asking for window name and matrix. And the name of the window that I want to provide is any name, let's say, and this is what my original image or something like this is my original image, and this is the matrix I just need to provide here. Means the matrix I need to provide here is img, and which has some image array img. And immediately after that, what we need to do is that we need to specify the wait key. So if I specify the wait key, and what it indicates, like, how much time delay I just want to display this image. What are the image that we have displaying in some window? How much time delay I just want to display it. And remember, the time is measured in milliseconds. For example, if you put 10, indicates that it will wait for 10 milliseconds. If you put for 1000, it will wait for 1000 milliseconds. That means 1 second. And if you put 10,000, it will wait for, means the window it will display for 10,000 milliseconds, that is 10 seconds. So that let me write it here, like, this command will display the window for n milliseconds. So here we have 10,000, means n indicates 10,000 milliseconds. So once we're done with the 10,000 milliseconds, my next command will be, I just want to close it. So in order to close that, we use the command destroy all windows. So that's it. So this is what I just want to do here. This is what the way of displaying an image. Execute it. You can see that this is what the image, and it will wait for 10 milliseconds, and immediately after 10 milliseconds it will get closed. You can see that. Let me execute one more time. It will wait for exactly 10 seconds, and after that this window will get closed. Yes, so this is what, like, the wait key is going to do here. In order to display the image, let's say I just want to display the image for infinite number of times, or in a simple way, like, I just want to display the image until unless I manually close the window. In that case, what we will do is that we'll specify the wait key to 0. So this command will display the window until you press X, or, like, any keyboard key, any key. So let me execute this. Now you can see that it will get anything until unless if I press on close, it will close it. Or here I'm pressing any keyboard button, and now it is getting closed. So that's what, like, the use of wait key. In going forward, what we will do, we will use the wait key of 0, which means that I just want to display the image until unless I pressed any button. Okay, so this is what, like, one of the method of displaying an image. There is one more method of displaying the image, is displaying within the browser itself. Means, like, just like we are printing any kind of values, just like that I just want to print an image. So that's one more method. So in order to do that method, what I will do is that I will use one more library called matplotlib. Using the matplotlib, I will plot it. Basically, I'm doing some kind of chart. So let's do that. Let's import matplotlib. Import matplotlib .pyplot as plt. Execute it. Now we can display the image using the matplotlib. So plt.mshow, just like the cv2.mshow, we have the plt.mshow, And here we just need to provide the x. X is basically an array. So here the array is what is basically we just need to show an array that which we want to display. So the array that I want to display is img. And now plt.show. In order to show that, we will use this plt.show. Now execute it. Perfect. Now you can see that here we can able to display the image inside the browser itself. Okay, you might wonder, this is not the original color of the picture. Means this is the original color of the picture. What we have is the yellow and some green and some what we have is some reddish here, something like this. But what happened here is that it is changed completely. The reason behind that is Matplotlib assumes that image is in RGB format. Assumes that image is in RGB format. So that's what the problem with this. Since we read the image in the BGR format, and that's the reason wherever there is a blue is there, it is being replaced by red, and red is replaced by blue. That's why we got this. For example, this person wears the blue color and it shows like something like a reddish. This is what the problem whenever displaying with a Matplotlib. And the quick remedy for that is that simple indexing. Just like NumPy indexing, just selecting all rows and all columns. Now just reverse that pixel values, means the image whatever we have is in BGR format. I just want to display in RGB format. So this is 2, 1, 0, what indicates I'm just reversing the picture colors. So what I'm doing here is that as img is BGR format, so I'm just replacing that blue with red and red with blue. So that's what I'm doing here. 2 is basically I'm just putting red is the first place and followed by green and followed by blue. So that's what exactly I'm doing here. Now let's execute that. Now we can see that we have our original image. Okay, so this is how we can display any image using Matplotlib and also using OpenCV mshow. Hey guys, welcome back again. In the previous lecture we have seen how to display the image. Now let us see how to save this image. You can save the image using OpenCV cv2.imwrite. Imwrite is basically using this command we can save the image. What we need to specify is that we just need to specify the name of the file name that we need to save and the format. For example, let me save this with the file name. Let's say in the images, I just want to save in the images folder, and this is save.png, and that's what the extension and the name I just want to save here. And the next what I'm to provide is that array. Basically, what is the array I just want to save? And the array I just want to save is img. Now execute it. And as you said, the moment you'll get true, it indicates that you have saved the image successfully. Suppose you got false, it indicates that your image does not able to save successfully. That's the meaning of this. Okay, anyway, so now in this case I got true. So let us look into our folder and let's see whether we have able to save our image or not. Alright, I'm in my folder and you can see that this car001.jpg and save.png is what the name of the file, and that is what I've saved. And you can see this, I can able to save in the different format. That's it. So this is how you can save any image you want. I'll see in the next lecture more on basics of images with OpenCV. Hey guys, welcome back again. In this lesson, we will see how to load an image, display the image, and save the image in some different format. Okay, in the complete image processing technique, we are working on Jupyter Notebook. So what we will do now is that let's open our Jupyter Notebook and load the image from there. Now let's first open the Jupyter Notebook. You can open the Jupyter Notebook by click on search and type cmd, command prompt, And what I will do is that since I just want to work my Jupyter notebook in this current working directory, so what I will do is that let me copy the path, where exactly you want to work on, and now paste it here. cd space paste the path of your current working directory and press enter. Since I'm in the D drive, that's why I'm just navigate to my D, and now we can see that this is what the path has been set successfully. Now let us open the Jupyter notebook here by the command Jupyter space notebook. Execute it. As soon as you execute the command, and your Jupyter notebook, it will open in your default web browser. Wait for a couple of seconds until your Jupyter notebook has loaded successfully. Here we go, and this is what my Jupyter notebook has been loaded successfully, and this is what my current working directory. And as you can see, this is what the images folder, and inside that we have few images. Now let us open the Jupyter notebook. You can open the Jupyter notebook by click on new and click on Python 3. This will open the new notebook. Wait for a couple of seconds until your notebook has initialized successfully. Yes, so my notebook has initialized successfully with the name and title. The first what I will do is that let me rename my Jupyter notebook with 1 underscore. Let me name it as I just want to load an image, display the image, and save the image and execute it. So I just want to rename this with the whatever the name I want. The first library that you want to import before OpenCV is NumPy. Import NumPy as NP. NumPy is a numerical Python library which is basically the dependency for OpenCV. That's the reason before importing Computer Vision CV2, we need to import the numerical Python. It need not be necessary like you are using that, but OpenCV library will use it. So that's the reason it is better to import the numerical Python library before CV2. Now let us import our OpenCV library, which is CV2. So this is my OpenCV library. Use the keyboard shortcut Shift+Enter, that will execute this cell. Now let us load an image using OpenCV library. You can load an image by the variable img equal to cv2 dot. cv2 basically represents the library OpenCV, and we are using the module imread. imread is basically stands for reading an image. You can open this docstring using the keyboard shortcut Shift+Tab, and what you can see here is that this function will load the image from the specified file path. So what we need to provide here is that we just need to provide the file name or the path where exactly your image is. So let me specify the path of the file, and since I just want to load an image and I know that my images are there in the images folder, and wherever your folder and wherever your image is, you can just simply set the path and it will load the image. And the image I just want to load here is car001.jpg, and execute it using keyboard shortcut Shift+Tab. That's it. So this is how you have load an image successfully. Now let us print the image. Whatever the variable we have, let us print it. Print img. Execute it. As soon as you execute that, this is what the image, and it looks like something like this. Any image that was loaded from the cv2 imread command will be loaded in a 3-dimension array. So the array is basically a 3-dimension array. So the first dimension represents the number of rows, second dimension represents number of columns, and third dimension represents the channels, basically number of channels: red channel, green channel, and blue channel. So that's what this basically represents. And remember one thing that OpenCV will read an image in BGR format, means blue comes first followed by green and red. So that's what you need to keep in mind. And as I said, in the previous lectures, we discussed that the pixels is the range of values between 0 to 255. Since this is a color image, so this tuple represents one single pixel. Means this represents the weightage of the blue color, this represents the weightage of a green color, and this represents the weightage of the red color. So if you combine all together, we'll get one color. Basically these three parts, 120, 115 and 106, represents one single color or one pixel. Awesome, right? And one more point I just want to mention here is that all the images that was read by this following command is 8-bit image. So since the image that we are reading is an 8-bit image, so the range of pixel values is between 0 to 255. Means that all the values whatever is there inside the pixel are between 0 to 255. So you can check that by looking into the minimum and maximum value. So img.max, so basically the maximum value could be the 255 and the minimum value is 0. And the minimum value inside this array is 0. And then also you can look into the shape of that. It's basically very much similar to the numerical Python array. So you can look into that by looking at the shape of that, and it says that we have 423 rows and 678 columns and 3 channels. Remember again, the channel starts with blue, green and red. Okay, so this is how you can read any image. And one more thing you need to keep a note that whenever you executing this command, OpenCV will not throw any error if that image does not exist. For example, let me load one more image. It is cv2.mread, and let's say it was, I'm just set the path is my images folder, and you can see here there are 3 images are there: 0021.jpg, 2000 and 2200.jpg and card.jpg. So let's say, let me read some random image. Basically that image is not there with me, and just mention like jpg. This image is not there in this any particular folder, but when you load that, OpenCV will not throw any error. It will not give any error. Basically it says like image not found, and image cannot be loaded successfully or something like this. So it will not throw any error. Basically whenever the image is not there, it will not throw any error, but we can look into that by looking to 6. Whenever you're printing this, there is nothing. And you can look into the data type of this, and if you look into the data type of this, it will show you the none type. So that is what you need to keep in mind here. So whenever the type of the image, whatever you read, and this is a none type, it indicates that OpenCV did not read that image. Means that maybe that image is not present, and you need to specify some other folder or some other image properly. So that thing you need to keep in mind whenever you're loading any image. Whenever you load an image, you can't display all these things, and if you get none type, it indicates that that image is not there. Alright, so this is how you need to load an image. Hey guys, welcome back. In the previous lecture, we have seen how to load an image, display the image and save it in a different file format. Now in this lecture, we will see how to access and manipulate the pixels using OpenCV. So first what I will do is that let us load an image, and the image that I'm going to consider in this case is the same image which I used in the previous lecture. So let us load the image and save it in the variable img. So img equal to cv2.mread, and as I know my images is in my images folder, and the image that I'm basically interested is cars001.jpg. Execute it, and let us look into the shape of an array, imd.shape. And what we can see here is that we have 423 rows and 678 columns, and we have 3 channels: B, G, R. B stands for blue, G for green and R for red. Now let us display the image what we have read. So we can use a cv2.mshow followed by cv2.waitKey of 0 and cv2.destroy all windows. Using that we can do that, and every time writing that is highly not recommendable. So what we will do, we'll write a simple function, and using that function we will load the image. So let us write a function and name it as display. def space display, and the argument that I want to pass here is WinName, means basically the name of the window, and the image array. And after that we have to show the image using imShow, and we know that the first argument in imShow is WinName and second argument is mat. Mat is basically array or the image. So WinName is basically the input is coming from the display first argument WinName. So let me pass it here, and the name of the image array is image, which is my image. Now the next step what I'm going to do is that let us put some weight key of 0, and finally we will do display or destroy all windows. Execute it. Alright, so we have successfully created the function display. Now what we will do, let us display the image using the display function. Display, and I know that the first one is the WinName, and the WinName that I want to create is, let's say, the cars, and the matrix that I just want to display is image. Execute it. Perfect. So this is what the image which I have loaded successfully. And what you can understand from this image is that we have 423 rows and 678 columns. Rows is defined by the height of an image. So basically it says that the height of the image is 423 pixels and width of the image is 678 pixels. So that is how we can define the rows as a height and columns as a width. Now what we will do in this lesson, we will try to access the pixels from it. So here I just want to access, let's say, first 300 rows and first 300 columns. Let's say maybe I just want to access this portion of the image. So let us see how to access those pixels. So before moving further, let us look into the data type of the image by using the type of img, and what you can see is that the img, which is an array, is basically a numerical Python array. So this matrix has all the properties that was there with the numerical Python array. So we can slice it, we can manipulate it, just like how we do for the numerical Python. So we can do exactly the same thing with the numerical Python array. Anyway, so what we will do now is that my question is that I just want to access first 300 rows, and bracket is basically the height, and first 300 columns, which is nothing but the width of the image, nothing but my numpy array. Okay, so how to do that? So basically we can do exactly the same thing how you slice it for the numerical Python array. Just like that we can do it. So take an image img and use the square braces, and 0:300 is basically we are asking for first 300 rows, comma, and 0:300, the next 0:300 is asking for the first 300 columns. So that is how we can access the image. So let me name it as ROI and execute it. So we can display this ROI using the display function. Let's say display, and this is what my access, and let us display the image, and the name of the image is ROI. Execute it. So this is what the ROI, basically this is what we have cropped, and you can see we can access the pixel of first 300 rows and first 300 columns. Awesome, right? It is really very easy to access the pixels using OpenCV because it is very much similar to numerical Python. I will see you in the next lecture on how to manipulate the pixels using OpenCV. Welcome back. In the previous lesson we have seen how to access the pixel of an image. Now in this lesson we will see how to manipulate the pixels in OpenCV. Okay, so we know that the accessing the pixel is almost similar to the array slicing. Just like array slicing, we will replace the numpy values to some value which is nothing but the manipulating the pixels. In the previous lesson we extracted 300 rows and 300 columns. So what we will do is that now we will not only extract the first 300 rows and first 300 columns, also we will replace that first 300 rows and first 300 columns with a green color. So that is what we're going to do in this case. So let us define the green pixel now. So green pixel can be defined as a tuple of 0, 255, 0. So this is basically defined one pixel and the color is green. Now what I will do is that let us manipulate the pixels. Means I'll take the first 300 rows and first 300 columns and I'll replace them with the green pixel. So how to do that is almost similar to this. So img of 0, 300 and 0, 300 is basically accessing first 300 rows and first 300 columns, and now I just want to replace them with a green pixel. That's it. Execute it. So done. So what we have done is that we have manipulated our image. Means we not only access the pixels, also we have manipulated the pixel here. So let us display it using the display function. Display, and this is manipulate, comma, and the name of the image is img. Execute it. Now here you go, you can see that we have not only accessed it, but also we have changed that into the green color. So this is how we can manipulate the pixel values to what are the desired value you want. Awesome, right? Now what do? Just play with the what are the images you want, just access it and manipulate it with the different colors you like. I will see in the next lecture more on image processing with OpenCV. Until then, happy learning. Hello everyone, welcome back. In this lesson, we'll talk about the color space. A color image consists of the multiple channels, red, green and blue components. We have seen that we have accessed these components via indexing into NumPy arrays. But what if we want to split an image into the respective components, that is red image, blue image and green image? So what I'm trying to say is that we know that image is basically the combination of three channels, red, green and blue. So in this lesson, what we will do, we will split these three components and let's try to analyze what the red image consists of, green image consists of and blue image consists of. In this lesson, what we will do, we will consider this image and we will split the three components in this image and see how it looks like in OpenCV. So let us go to our Python and import all the necessary libraries, that is NumPy and OpenCV. Now let us read an image, and img equal to cv2.imread, and the name of the image is the images folder, and this time the name of the image is 3cars.jpg. And let us display the image using cv2.mshow, and this is what my original image, and the name of the image is img. Next, cv2.waitKey of 0 and cv2.destroy all windows. So this is what the image we are considering now. So we know that this image is basically consists of three channels. Let's look into the shape. And if you look in the shape, that we have 795 rows and 1200 columns and 3 channels. Using OpenCV split command, let us split that into 3 different matrices. Anyway, the first matrix is B. Since the image that we read is in the BGR format, like B comes first, followed by green and followed by R. Means the first matrix, what you'll get is the blue image, and the second matrix is a green image, and the third matrix is a red image. Let us split that using cv2.split command. So B, G, R equal to cv2.split. And here I just want to provide the array or the image which I just want to split. So in this case, it is img. So perfect. Now what we have is that we have splitted our image into 3 different components, blue, green and red. B consists of information about the blue color, and G consists the information about the green color, and R consists the information about the red color. So let us print the B here. If you print the B, it's basically a 2x2 array. Unlike img is basically a 3-dimension array, and whereas the B is basically a 2-dimension array. So even the G is also the 2-dimension array. And you can see that all BGR or the two-dimensional array. Basically, if you combine 3 channels, you will get one image. Anyway, so what we will do, let us separately display BGR and try to understand what exactly happening in that image. So let us display that using the command mshow. So cv2.mshow, and this is what my blue image, and the array is blue, and cv2.mshow, and this is the green image. Basically, this green image consists of information about the green color, which is nothing but G, and cv2.mshow red image, which basically consists the information about the red color. And also let us display my original image. So this is my original image, img. And now let's specify the wait key of 0 and cv2.destroy all windows. Execute it. Here you go. What we have is that this is what my original image, and we split this original image into 3 components. This is my blue, and this is my red, and this is what my green. And what you can understand here is that each and every image has different sorts of information. So basically, if you look into this blue image basically consists the information about the blue color. The lighter or the value near to white color, nothing but 255. Basically this is where the blue color present, and rest all is we have very less amount of blue is there. So what you can see here is that this is the car is basically consist of the blue color. So that's what you can see here in this image, and this is what the original image. As you can see, this is my blue car, and the blue image, this is what much more lighter. And let us consider one more image. This time it is a green, and as you can see the green image, and we have the car in the middle is basically very much lighter in color. So this indicates that this is the portion where the green color is present. So let us look into that. So obviously this is what my green color. And finally let's look into my red. Obviously you can see this is what the car is very much lighter. So this here we have the rich information about the red color. Let us look into my original image. Obviously this is what this. And now what we can understand is that if we combine the 3 images like red, green, and one more is blue. This is if you combine 3 images like this, and what you can get here is this image. I will see in the next lecture more on the color space. Until then, happy learning. Welcome back. In the previous lesson, we have explored the RGB color space. However, there are different spaces that we are going to utilize. Hue saturation value color space is the most similar to how humans think and conceive of color. There is another color is L star A star B, nothing but LAB is also a color space which is most tuned into the human's perspective color. OpenCV provides many different color spaces, and understanding how the color is perceived by the human and representation by the computer occupies an entire library for the literature itself. In order to not go down into the details about this, I will show you how to convert the colors using OpenCV. If you think your application of image processing and computer vision might need different color space than RGB or BGR, I will leave that as an exercise to read to more explore the peculiarities of each color space. Now let us explore some code to change the color space. So now what I'm going to do is that let me use the different image now. Let us first load the image. So img1 equal to cv2 dot, I'll read one more image, and this time the name of the image is in images folder, and this time it is beach.jpg image. Execute it. Let us display this image using cv2.mshow, and obviously we need to provide the window name. Let's say this is my original image, nothing but my BGR image. Let me write the BGR for the more specific way, then what you need to provide is mat. Mat means basically the matrix img1, and finally cv2 dot weight key of 0 and cv2 dot destroy all windows. Done. Now execute it. Okay, this is the beautiful scenery. What we have is the beach and some coconut trees. So what we will do, let us apply some filters to this image, and let's see how exactly our image is going to be work now. Let us close this. Now what I'll do here is that let me use the color space that was available in the OpenCV and try to convert that into different color space. The first color space what we will see is that converting into BGR image to gray. Basically this is the BGR format. So what I need to do is that the first color space, let's see, converting that BGR image to gray. Also we will see how to convert BGR to RGB, and we'll also, the third one, we will see BGR to HSV, which is the most widely used, and 4 is BGR to LAB. Okay, so all right, so step by step we'll see and try to understand how exactly it's going to work. So first let us convert that BGR to gray. So gray equal to cv2 dot, we have a method in OpenCV which is convert color, and if you open the doc string using the command shift plus tab, and what you can see is that source, which is my source image, nothing but input image, in this case img1, and I need to provide the what is the color space code I just want to use here. So let us see how to do that. Okay, anyway, the source image is src is img1, and the color code is, so for in order to get the color codes, you need to use the cv2 dot and use the capital letters color, and if you press the tab you can get all the autofill like color underscore BGR. Since my format, the default format is BGR, and just provide the BGR. Now you can see there are different color spaces are there. However, we will see the 4 different color spaces, and for your sake of interest you can also look into all the different kinds of color spaces. Anyway, so here, which is the BGR to the first color space I want to use is gray, and you can search for BGR to gray here. That's it. So this is how you can convert that any image which is in BGR into gray. Let us display this, and in order to display that, let's use cv2 dot mshow, and this is what my original image, which is my BGR format, and the name of the image is img1. And also let us display the gray, cv2 dot mshow, and this is my grayscale image, and the array of the grayscale image is gray. That's it. And finally let's use the cv2 dot weight key of 0 and cv2 dot destroy all windows. Execute it. Awesome. This is what my original image, and this is what my grayscale image. Awesome, right? You can see that this is a perfect grayscale image, and this is the color image and grayscale image. Alright, so now what we will see, we will look into the one more color space which is converting BGR to RGB. We can also do that BGR to RGB equal to cv2 dot convert color, and here the source image, nothing but my input image is img1, and this image I just want to convert that into RGB. So in order to do that, we will do exactly the same way what we did for the grayscale, which is cv2 dot color underscore BGR2, and if you press tab you can get the autofill, and now just select what you want. Since I just want to convert BGR to RGB, click on this. That's it, and let us display it. Okay, cv2 dot mshow, and this is what my this is what my RGB image and this is image underscore RGB. That's it. Let us display it. This is my original image, and this is my RGB image. This looks like cool, right? And this is what my grayscale image. It's really like what happens here, like wherever we have the blue, that is being replaced by red, and the red is being replaced by blue, and green still remains same. For example, you can see there is some reddish behavior is there, and that is going to be converted into blue. Okay, so that's what the basically difference between BGR to RGB, just basically the change of colors. Let us close this, and let us also look into the color space BGR to HSV. So img HSV equal to cv2 dot, same method, convert color, and source image is img1, and this time I will change the color code to BGR to HSV. HSV stands for hue, saturation, and value. Let us display it. cv2.mshow, and this is what my HSV, and image underscore HSV, execute it. This is my original image. Let me minimize this. This is the HSV image, and this is my BGR image, RGB image, and this is what my grayscale image. Awesome, right? And one more image that was most widely used apart from HSV, it is LAB, basically L into A into B. I just don't want to go more details into that. Let us see how to convert that colors. So img underscore LAB equal to cv2 dot convert color, and source image is img1, and what we got going here is that in the color code is change the color code to BGR to we have LAB, execute it. And finally, let us display this. Just copy this and paste it here. What we will do, this is what my LAB, and copy, paste it here. That's it, execute it. So this is what the color codes what we have. This is my original image, and this is what my LAB image. It looks like more like a segmentation, right? Let me look into one more image. This is what my HSV, basically HSV and LAB look more similar, but there is a blur effect in LAB. This is what my RGB image, and this is what my grayscale image. Awesome, right? This is all about the color space in OpenCV. I'll see you in the next lecture, more on image processing with OpenCV. Until then, happy learning. Hi, welcome to the module Image Processing with OpenCV. This module has 3 sections. Those are the sections 3, 4, and 5. Section 3 is about the image basics with OpenCV, where we'll put our interest towards the basics of images and understanding the OpenCV syntax in Python. And section 4, object detection with Viola-Jones frameworks like face detection, eye detection, etc. In section 5, I will taught you about face detection and feature extraction with deep neural networks. You can skip this section straight away and go to section number 6 if you're already aware about the OpenCV Python. Our intention of this section to keep in mind for all sorts of audience. Let us go into the section and get more details about this. Hey everyone, welcome back. In the previous lessons, we have seen how to deal with the color spaces. Now we will see how to draw straight lines, circles, rectangles, and polygons in our image. Luckily, OpenCV provides a convenient, easy-to method to draw the shapes on the image. In this lesson, we will see the most basic methods to draw the shapes in OpenCV. Before we exploring the drawing capabilities of OpenCV, let us define our canvas in which we will draw our masterpiece. Up until this point, we have loaded our image from the disk, but however, we will also define our own images manually using NumPy array, given that OpenCV interprets as an image as NumPy array. Therefore, there is no reason why we can't do the manually define our image ourselves. First, let's import our necessary libraries, OpenCV and numerical Python. Execute it. So now what I will do is that I'll create my own image and name it as a canvas. And here my canvas is in black color. In order to create a black pixel, I just want to fill my array all the values to 0. As we know that any value closest to 0 is dark in color, basically black. For 0 it is black. So now let us define our canvas. Canvas equal to, using numpy, np dot zeros, and I just want to create the shape of my canvas. In the shape of the canvas, I just want to create a 300 by 300 pixel, and the 3 is basically define the shape of an array. And this is very important. I need to provide the data type of my image. Remember, the data type of an image is an unsigned 8-bit integer. So let's specify the data type to be unsigned 8-bit integer. So which is uint8. So that's it. So this is what my canvas. And if you execute this, your canvas has been created successfully. Let us display it using OpenCV. In order to display that, I can use cv2.mshow, and this is what my canvas, and the name of the array is canvas. Also provide cv2.waitKey of 0 and cv2.destroy all windows. Execute it. Here you go. This is what my canvas with 300 rows and 300 columns, and the color is black. So what we will do in this canvas, we will try to draw a line, rectangles and also circles on this canvas, and try to understand what we can do more in this drawings. The first and foremost thing what we will do is that let us try to draw a line, something like in a diagonal point. For example, if we execute this image and I just want to draw a line from this point to this point. Okay, so in order to draw a line for OpenCV, we need to provide the arguments from point 1 and point 2. So between these 2 points, OpenCV will draw a line. So let us see how to draw a line here. Line. In order to draw a line, we have a method called cv2.line, and here I just want to provide the img, which is what my input image, and point 1 and point 2 as a mention that point 1 and the point 2 are the 2 points and between which my OpenCV will draw a line. And color is basically what color you want to draw, and thickness indicates what is the thickness of a line in pixels. Okay, so since I just want to draw a diagonal line between some 0, 0 to 300, 300, so let me define my point 1. So point 1 is basically tuple, and at what is a point, and point 2 is another point, and between which we will try to draw a line, and point 2 to 300, 300. And the color I just want to draw here is, assume that it is a green pixel. For a green pixel is a tuple of 0, 255, 0. Basically we need to fill the green bucket. Alright, so I think everything is done. So let us draw a line now. What we need to provide is image, which is my canvas, and point 1 to pt1, and point 2 is pt2, and the color is my color. For time being, let us not specify the thickness. If you are not specifying any thickness, it will assume to be a 1 pixel. Okay, so this is what my line, that's it. So let us display this image. We can display the image using cv2.mshow, and the name of the window is canvas, and this is what my canvas, and cv2.waitKey of 0 and cv2.destroy all windows. Execute it. So that's it. So this is what my canvas. As I said, we have the diagonal line between the point 0, 0 to point 300, 300. The color which we drawn is red color. Awesome, right? So I'll see you in the next lecture more on this line and also how to deal with the thickness of the line in next lecture. Until then, happy learning. Welcome back. In the previous lesson, we have seen how to draw a straight line, and in this case we have drawn a line between from this point to this point. So in this lesson we will see how to draw one more line, and this time we will draw from this point to this point, and this time we will increase the thickness of the line. And moreover, we'll also add, instead of green color, let me put some other different color like red. So let's see that how to draw a line. Okay, so I'm using the same canvas, whatever I'm having here, I'm using the same canvas, and this time I'll change the point 1 to, since this is the point we are going to consider, and the point at which we are having is rows is equal to 0 and columns is equal to 300. So point 1 to be 0 comma 300, and similarly point 2 is 300 comma 0. So this is the 2 points that we are going to consider now. Alright, so let's use the same code exactly what we had is cv2 dot line, and the image name is canvas, and the point 1 is 0 comma 300 and point 2 is point 2, and the color what we are going to do in this case is red color. Since it is a BGR format, blue comes 0, G 0, and 255 you fill with the full value, that is 255. And the one more argument that you are going to look in this lesson is thickness. And the thickness is basically measured in terms of pixels. Let's say if you put the thickness is equal to 5, it indicates that the line what I is going to draw is with the thickness of 5 pixels. So that's what we're going to draw now. So let us display this image. Let me do one thing. Let me copy this and paste it here. Now execute this. Here we go. This is what the line we have drawn, and this is the previous green line which is already drawn, and on top of that what we did is we drawn a red line with the thickness is equal to 5 pixel from the point 1 to point 2. Awesome, right? I'll see you in the next lecture on how to draw the rectangles using OpenCV. Until then, happy learning. Welcome back. In this lesson, we will see how to draw the rectangles on our canvas. So this time what I did, I took the different canvas with the np dot zeros of 600 by 600, means we have the width is equal to 600 and height is equal to 600. So I just saved that in my canvas, and let me display the image. So this is somewhat bigger canvas what we have, and now what we're trying to do is that I will try to create the 3 different types of rectangles. Like one is without any thickness, and second is by adding some thickness, and the third we will fill the rectangle. So we will see that 3 types of drawing a rectangle. Just like similar to the cv2 dot line, we have the cv2 dot rectangle, and we have the arguments more similar to it. So what we have is that we have an image, and we have the point 1 and point 2, color, thickness, and line type, something like this. So basically what we had is that we will have same arguments what we had for our line. But here the point 1 and point 2 indicates the 2 diagonal points of a rectangle. So let's see how to draw a rectangle to our image canvas. So what I'll do is that let me take point 1 and point 2, which are my 2 diagonal points. Assume that, let me consider the diagonal point to be 50 comma 50 is what my point 1, and one more diagonal point is assume that this time I'll take for 100 comma 100. So this is what the point what I'm having with me. And first and foremost thing what I want to do is that let me draw a color, and the color I just want to draw here is blue color. So blue, for order to draw a blue color, just fill the blue portion to fill like 255 and rest to 0 comma 0. So that's it. Alright, so now let us draw a rectangle using cv2 dot rectangle. So what I need to provide here is image 1, which is what my canvas, and point 1 to pt1, point 2 to pt2, and color to color, and that's it. So what we will do now, let us display our image. So cv2.m show, and this is what my canvas, and canvas, and cv2.weight key of 0, and cv2.destroy all windows. Execute it. As you can see here, we have a blue rectangle box is appeared here. So which is basically the two diagonal point as I mentioned. This is my 50, 50, and this is what my 100, 100, the two diagonal points. That is what we drawn here. So let me draw one more rectangle here, and this time the rectangle I want to draw here is with the thickness, with the different kinds of thickness. So for that, what I will do is that let me take the same rectangle, and on top of that we'll add it on the canvas, and I'll change the different points pt1 and pt2. This time what I'll do, I'll take some my pt1 to 100, 100, and pt2 to, let me take 200, 200. Okay, thickness in terms of pixels. So let me take the 5, and the color I just want to draw here is let me take some green color. So the green is 0, 255, 0. Okay, so let us execute this. Oh, I'm sorry. So basically first is color and followed by thickness. Now execute it. Here you go. This is the blue one, and this is what my green rectangle box. And this time I'll draw one more rectangle box, and here basically I'll fill it. Basically what I'll do, I'll try to fill my rectangle box. So let me do the same cv2.rectangle, and this time I'll change the points to 200, 200, and the end point is 300, 300, and so the color I'm just going to go for red color is 255, and 0, 0, 255, basically the red color. In order to fill the rectangle box, you need to use -1. The -1 will basically understands that we need to fill the rectangle box with this color. Okay, now let's execute this. Here we go. We have some red color, and this is the box which was filled with the red color. Awesome, right? So this is the 3 rectangles which we drawn. One is the blue, green, and red. What are the rectangle? What are the color you want? What are the thickness? Whether you want to fill it or not, we can easily do it with cv2.rectangle. I will see you in the next lecture on how to draw the polygons in OpenCV. Until then, happy learning. Hey everyone, welcome back. In the previous lessons, we have seen how to draw a rectangle and also drawing a straight lines. Now in this lesson, we will see how to draw the polygons. OpenCV is not only limited to drawing the rectangles or lines, we can draw whatever the shape you want. So let's create a canvas. Canvas equal to np.once. In the previous 2 lectures, we have seen the drawing in the black canvas. Now we will take the white canvas. So in order to define the white canvas, I just want to create the ones, and the shape I just want here is 600, 600, and 3. Obviously the data type to be unsigned 8-bit integer. Anyway, so we got the ones. So in order to get the white color, I just want to multiply that with 255. So with this I can get the white color. So let us display it. You can display cv2.mshow canvas and canvas, cv2.weight key of 0, cv2.destroy all windows. Execute it. Here you go. This is what our white canvas. In this canvas, what I want to do is that I just want to draw one hexagon. So let me define the points of the hexagon here. So the points of the hexagon is, let me define in np.array, and so the first point is 200, 200, 250, 300, 350, 300, You can take what are the points you want, because this is the point that I calculated, so that's the reason I'm giving you these points. 400 comma 200, this is in net list. Okay, next is 350 comma 100, 250 comma 100. Okay, so remember what are the points we have. It should be in the two-dimension array. So let me take these points and pt dot reshape that into -1 comma 1 comma 2. Okay, now let's take the polygon module in OpenCV, which is cv2 dot polylines. Now here I just want to provide the img is basically my source image is canvas, and the points or this points pts, and is closed is basically this is the binary. Do you want to close or do you want to open? So this is the binary value. Let me put the false at the moment. And the color, I just want the color to be, let's say, blue color. Let me take the blue color. It is a tuple of 255, 0, 0, and the thickness is 5 pixels. So let me display it. So cv2 dot mshow canvas cv2 dot weight key of 0, cv2 dot destroy all windows. Execute it. We should supposed to get the polygon here. Yeah, I think we should give the list here. It's a list of pts. Yes, cool. Now we can see that this is what the polygon what we have. And remember, like the polylines I mentioned, like lines to be false, so that's the reason it is not get connected. So if I specify to true, I can see that these lines are getting connected. So this is how you can draw a simple polygon, provided you have the points. If you have a points, then you can draw what are the shape you want. So let me do one thing. Let me create one more polygon, and this time maybe I'll change the coordinates. So here what I'll do, let me take, this is a 200, just a shift. I'll just give one shift, and 100, this is 250, this is 300, 250, and 150. I can give the different color here. You can give what are the color you want, and it's not only blue, green, and red. We can also have the different colors. Just fill this time I'll fill it with 255, 0, 255. I can get some different color. The color might be the magenta. So let's see that. It's okay. This is cool, right? You can see that the blue color is what this line, and the magenta or the pink line is this code. It's really awesome, right? How drawing what are the shape you want, provided but you should have the points to draw what are the lines you want. But anyway, this is really the cool way of drawing the polygons using OpenCV. I'll see you in the next lecture more on image processing basics. Until then, happy learning. Welcome back. In this lesson, we will see how to draw circles using OpenCV Circle. Let us create a canvas again, and in that canvas, let's draw the circle. So let me create the canvas. Canvas equal to np.once, and this time I just want to create the shape of an array between 600 rows and 900 columns, and comma 3 is what depth of an image, and data type to unsigned 8-bit integer. Alright, so this is what my canvas. So let us display the canvas. cv2 dot mshow canvas and cv2 dot weight key of 0, cv2 dot destroy all windows. Execute this. Okay, since I want to create some white canvas, so what I'll do, I'll just multiply this with 255, and this time I got the white canvas. So let us draw the circle on top of the canvas. So let us create a circle here, cv2.circle, and here you go, you can see that the doc string is we need to provide the image and the center of the circle and the radius of the circle, color and thickness. So what we will do is that, for time being, let us consider the center of the circle to 100, 100, and the radius is 100. So let us create it using this image canvas. Center is 100, 100, and the radius is 100 pixels. So the color I just want to create here is that, let me put some blue color, 255, 0, 0. And obviously the thickness, negative values is indicates you are closing the values, and the positive value is basically the thickness of the line and pixels. So let me take the 5 pixels, and this is what I'm getting here. So let us display that, cv2.mshow, and this is for my canvas. Canvas and cv2.weight key of 0, cv2.destroy all windows. Execute it. Here you go. What you can see is that, we can create a nice circle. So it's very simple. What you need to provide here is that center and the radius of the circle. So we can draw some abstract drawing. Let me create some logo. Maybe I'll create some Olympics logo. So let me create that. Basically Olympics, you know that Olympics is basically consists of 5 circles. So let us draw that. So this is 200. Let's say, let me give some space of 200. So since it is a 5 circles, let me copy this and paste the 5 circles. So we have the 5 circles now, and the first 3 circles on the top. So let's maintain the height to be 200, and now I'll change the width, basically my radius to 400, and this is to 700, and so we got the first 3 circles. And in the next 2 circles, let me bring the other 2 circles down. Let's say, let me bring this to 300, and this is also to 300 in order to get the same alignment. And now let me change that. Maybe I'll bring this in between these two, so it will be 250 and 550. And you can change what are the color you want. I can give the random color. This is the blue. This is blue. Let me give green here, and let me give red, 255, 0, 0, 255. And obviously I can give what are the color I want. It may not be BGR. I can give some random color, 255, 0, 0, 255, and probably this is also cool color, 255, 255, 0. So that's it. So let me execute this, and here you go. We got the circle, and maybe we got some extra circle. Let me execute this first circle again. Let me execute this canvas again and execute this. How is it, guys? So really awesome, right? So we can create any kind of abstract drawing using OpenCV. You can create the circles with a different radius and different colors, and you can also fill the color by adding some thickness is equal to -1, and you can get, so what are the shape you want, you can get using the polygons and etc. I'll see you in the next lecture more on image processing. Until then, happy learning. Hey everyone, welcome back. In this lesson, we will see how to put text in our image using OpenCV. Okay, so you can see that in the previous lecture, we have seen we created some Olympics logo. So what I have to do is that I want to put some text here, maybe Olympics, something like this. And that is what basically I just want to put. So let's see now how to put the text. OpenCV has a special module called put text, and using that you can put what are the text you want, you can put that. And here what you need to provide is that image, and the text. And what is the text you want to provide? And org is basically origin, means where my first letter should start, and font face, font scale, and color. Font face is basically the type of font, and font scale is basically the size of the font, and color, what is the color of the font you want. Okay, so first let us define the image. So image is basically the canvas, and the text, let's say I just want to create the text is Olympics, Olympics. That's what I want to create, a text Olympics. And origin, the origin is I just want to create somewhere between 200 to 500. That's what my origin. And font face is basically what is the type of the font. It is italic or what kind of font you want. And OpenCV by default consists of few fonts are there. You can use that. So for that, cv2.font, and this on all the the font options that was there. And so this is quite easy and quite cool. I'll use a plain font here, and the scale is, let's say I'll take the 5, and the color is, I'll go for the black color. So black color is 0,0,0 is what the black color, and thickness is 5 pixels. So now let us display this image. So we can display the image, use the cv2.imshow and canvas. You will use exactly the same thing. Now execute it. That's it. Here we go. You can see that we have the Olympics that is being displayed in our image. Excellent, right? So what are the position you want, and what are the color you want, what are the text you want, you can easily put into your image using cv2.putText. I will see you in the next lecture, more on image processing. Until then, happy learning.